Hi all, very good morning. Welcome to Chandan Loy's English YouTube channel. This is Joshna. In this session, we are going to discuss metallurgy, metals, non-metals and metalloids. Okay, from starting to ending, all of you listen this class very carefully. So in every examination, you can accept one question from this particular unit. Okay, very good morning one and all. Before starting the session, once all of you click the like button. So in this session, we are going to discuss what are metals, what are the properties of metals, and what are non-metals, and what are metalloids, and what are the classification we are going to discuss in this session. Okay, so even in our periodic table, we have metals, non-metals, and metalloids. So in detail, we are going to discuss. Very good morning, Joseph, baby, Manisha. All of you once click the like button. Okay. So actually, we have periodic table, right? So periodic table consists of how many elements, students? 118 elements. So that 118 elements consist of like metals, non-metals, metalloids, okay, and radioactive elements. So many of them are present in this periodic table. So in these periodic tables, the elements which are present at the left side of the periodic table are considered as metals, and the elements which are present at the right side of the periodic table are considered as non-metals. And the elements which are in the zigzag position between the metals and non-metals are considered as metalloids. In this session, we are going to discuss in detail, not 108 baby. So in our periodic table, as of now, we have 118 elements. Okay, as of now, we have 118 elements, and the 118th element is OG, that is the noble gas. Okay, yes, very good morning one and all. Vamshi, hi. So as of now, I have just discussed where the metals will be located in the periodic table. The metals are located at the left side of the periodic table, and the non-metals on the right side of the periodic table, and metalloids will be in the middle of these metals and non-metals. Metalloids will be located at the మీరు బ్యాక్ వెళ్ళి చూడొచ్చు వంశీ, ఓకేనా? ఓకే, సో మెటల్స్ అంటే ఏంటి? మెటల్స్ వచ్చేసి ఫౌండ్ ఆన్ ద లెఫ్ట్ సైడ్ ఆఫ్ ద పీరియాడిక్ టేబుల్. మెటల్స్ జనరల్లీ హ్యావ్ 1 to 3 ఎలక్ట్రాన్స్ ఇన్ ద అవుటర్ మోస్ట్ షెల్. అవుటర్ మోస్ట్ షెల్ అంటే ఏంటమ్మా? ఫర్ ఎగ్జాంపుల్, ఓకే, ఇది న్యూక్లియస్. సో న్యూక్లియస్ అంటే ఇది. సో ఇవన్నీ కూడా ఆర్బిట్స్ అనుకోండి. అవుటర్ మోస్ట్ షెల్ అంటే ద షెల్, ఓకే, ద ఆర్బిట్ విచ్ ఈజ్ ఎట్ the last orbit is considered as what, students? Outermost cells. And ఇక్కడ ఉన్న electrons మనం ఏమంటామంటే valence electrons. The electrons which are present in the outermost cell are considered as what, students? Valence electrons. ఈ metals కి valence electrons అనేవి ఏ విధంగా ఉండబోతాయంటే లైక్ 1 to 3 ఎలిమెంట్స్. ఓకే, outermost cell లో ఇలాంటి metals కి ఎన్ని ఎలక్ట్రాన్స్ ఉంటాయంటే 1 to 3. ఖచ్చితంగా గుర్తుపెట్టుకోండి. అండ్ ఈ మెటల్స్ అనేవి ఎప్పుడు కూడా ఎలక్ట్రోపాజిటివ్. ఎలక్ట్రోపాజిటివ్ అంటే ఏంటమ్మా? దే ఈజీలీ టెండ్ టు లూజ్ ఎలక్ట్రాన్స్, ఓకే, టు ఫార్మ్ క్యాటయాన్స్. క్యాటయాన్స్ అంటే ఏంటి చెప్పండి? క్యాటయాన్స్ అంటే ఏంటి? యానయాన్స్ అంటే ఏంటి? కామెంట్ సెక్షన్లో మెన్షన్ చేయండి. ఓకే వంశీ, సారీ. సో ఇప్పటి వరకు నేను చెప్పింది ఏంటంటే ఏం లేదు. మెటలర్జీ అంటే ఏంటి? మెటల్స్, నాన్ మెటల్స్ అండ్ మెటలాయిడ్స్. ఓకే, మెటల్స్ అంటే ఏంటంటే మనము ఈ కెమిస్ట్రీ పాయింట్, సో ఫిజిక్స్ పాయింట్ ఆఫ్ వ్యూలో అయినా కెమిస్ట్రీ పాయింట్ ఆఫ్ వ్యూలో అయినా చూసుకున్నట్లయితే మెటల్స్ అనేవి మన పీరియాడిక్ టేబుల్లో లెఫ్ట్ సైడ్ ఉంటాయి. నాన్ మెటల్స్ అనేవి మన పీరియాడిక్ టేబుల్లో రైట్ సైడ్ ఉంటాయి. మెటలాయిడ్స్ అనేవి మధ్యలో ఉంటాయి. మన అందరికీ తెలుసు మెటలాయిడ్స్ అంటే ఏంటమ్మా? విచ్ బిహేవ్ బోత్ యాజ్ మెటల్స్ అండ్ నాన్ మెటల్స్. ఇప్పటి వరకు నేను చెప్పింది ఇంతే. ఓకే, సో నెక్స్ట్ చూసుకున్నట్లయితే ఈ మెటల్స్ అంటే ఏంటంటే ఆల్రెడీ చెప్పాను కదా. సారీ, ఐఎమ్ ఎక్స్ప్లెయినింగ్ ఇన్ తెలుగు. ఐఎమ్ ఎక్స్ట్రీమ్లీ సారీ. Okay, I'm extremely sorry, students. Okay, what are these metals? These metals are nothing but, so the metals which are present, the elements which are present on the left side of the periodic table are considered as what, students? Metals. Okay, so they have 1 to 3 electrons in their outermost shell. Okay, these type of metals consist of 1 to 3 electrons in their outermost shell. That means this is considered as outermost shell. For these types of metals, the electrons will be 1 to 3. That means the electrons will be up to 1 to 3. and they are electropositive. Electropositive means what, students? They easily tend to lose electrons. Okay, they easily tend to lose electrons to form cations and act as a good reducing agents. And one more thing, students, metals are the good conductors of electricity. Okay, metals are the good conductors of electricity and they are the good reducing agents. Remember, very, very important. So, physically, they are usually solid at room temperature except mercury and gallium. Remember, very, very important. Even mercury and gallium, these two are also considered as metals. But all the metals are at a solid state at room temperature, but only the mercury and gallium, these two metals are liquid at room temperature. Okay, so what are the examples of metal, students? Copper, iron. Okay, so these are some of the examples of metals. Even mercury and gallium, these are also the examples of metals, but all the metals exist in solid state at room temperature. When comes this mercury and gallium, these two metals exist liquid state at room temperature. Remember, very, very important. And one more thing, students, which is the only non-metal which exists as liquid at room temperature? Tell me. Yes, cations are positively charged and anions are negatively charged. Very good. So these, okay, what are these, students? These metals, they easily tend to lose electrons. If they lose electrons, so what they will acquire, students? So automatically they are transformed into cations. Cations are nothing but negatively charged. So when the elements are easily tend to lose electron, they are considered as electropositive elements. Okay, remember, very, very important. And what are the examples of these metal, students? Mercury, gallium, copper, ferro, many are there. Okay, and the next thing, okay, high in tensile strength and possess high density except sodium and potassium. What do you mean by tensile strength, students? Tensile strength is nothing but pulling strength. Okay, for example, if we heat the metal, and if we strike it with hammer, so it will easily like pulled. That means it will be easily stretched. That means these metals will have high tensile strength. High tensile strength is nothing but either pulling or pushing. So pushing is compressive strength, that is different. Okay, pulling strength is nothing but what, strength? If we heat the metal, it can be easily transformed into either it will be increased its length or it can be decreased its length. So that type of strength is considered as what, students? Tensile strength. What are the examples of metals? Aluminium, copper, iron, okay, gold. So these are all considered as what, students? Metals. Okay, so next thing, very good. And these have the high density. High density is nothing but what, students? You all know what do you mean by density in Telugu. So I will only spill one word. In Telugu we will say it as Sandrata. Okay, so what is this? All the elements, all the metals have the high density except sodium and potassium. Okay, do you know, students? These sodium and potassium are stored in kerosene. Why? Because they easily react and evaporates. Okay, due to the very less density, these sodium and potassium are stored in kerosene. Remember this point, very, very important. Okay, students, as of now what I have explained, metals. So metals are nothing but, so where they exist on the left side of the periodic table. They are electropositive elements. Electropositive elements means what, students? They easily tend to lose electrons. That means they easily form cations. Cations are nothing but what, students? And positively charged elements. Okay, and one more thing, so they have very high tensile strength. Tensile strength is nothing but, so when we heat the metal and when we hit with a hammer, so it has the capability of stretching the metal. So that strength is considered as what, students? Tensile strength. Tensile is nothing but pulling strength. Okay, and compressive strength is nothing but pushing strength. Okay, what do you mean by tensile strength? If the dimension, if the length of the metal increases due to a certain force applied, that type of strength is known as what, strength? Tensile strength. And all the metals have high density except sodium and potassium. So these sodium and potassium always stored in where, states? In kerosene. Okay, very good. Next, non-metals. So what are those non-metals, students? I have already told you. So non-metals are located on the right side of the periodic table. Okay, they are electronegative. That means they easily gain the electrons. So they are easily gain the electrons and form anions. Okay, so know the difference, students. This non-metals or anions, they easily gain the electrons. When comes to metal, they easily lose the electrons and they are cations. Okay, located on the right side of the periodic table, non-metals plus hydrogen usually have 4 to 8 electrons in their outer shell. That means you all know this is outer shell, right? So in this, for non-metals, this outer shell consists of almost 4 to 8 electrons. So remember this, very, very important. When comes to metals, these metals consist of only 1 to 3 electrons in their outermost shells. When comes to these non-metals, it consists of 4 to 8 outermost shell in their valence electrons. Okay, so they are electronegative. As I told you, they are electronegative. That means they easily gain or share the electrons and form anions. Okay, they easily gain or share electrons and form anions and act as oxidizing agents. So metals acts as reducing agents and these non-metals acts as oxidizing agents. Remember, each and every point is very, very important. Okay, so they are typically brittle, non-lustrous except graphite and iodine. What do you mean by lustrous, students? Lustrous is nothing but slippy. Okay, they are non-lustrous except graphite and iodine. So these are in slippy nature. Okay, this due to the presence of lubricating property. Okay, this graphite and iodine, both of these elements have the lubricating properties, but all other metals except these two metals, they are non-lustrous. That means what? They are non-lubricating non-metals. Okay, so they are brittle. Brittle means what, students? Example, glass. Okay, glass is the perfect example for this brittle nature. It is easily breakable. Next, and poor conductors of heat and electricity except graphite. Very, very important. Non-metals are poor conductors of electricity and heat except graphite. Why? Because graphite is a good conductor of electricity. Okay. Next, metalloids. These elements located along a zigzag line between the metals and non-metals. So metalloids are nothing but which exhibit the properties of both the metals and non-metals. So in the periodic table, these metalloids are present between the metalloids and non-metals. So between the metals and non-metals in the zigzag line. Okay. So possess properties of both. Examples include boron, silicon, germanium, arsenic, antimony, tellurium and astatine. Remember, students, very, very important. So tell me, these are nothing but what's in semiconductor. The silicon, germanium, arsenic, these are the examples of what? Semiconductors. Okay. Now what do you mean by metalloids, students? In the periodic table, these metalloids will be located on the in between the metals and non-metals in a zigzag line. Okay. So these will have the properties of both the metals as well as the non-metals. Okay. And what, students? So these possess both the properties. What are the examples for this? Boron, silicon, germanium, arsenic, antimony, tellurium and astatine. So tellurium. So beside tellurium, which element will be present, student? Iodine. So we have already discussed it. Okay. Next. Up to 60% offers are going on Republic Day offers. Any course you can get it only for 499 rupees. Bank exams are also on offers. SSC exams are also on offers. Railway exams are also on offers. Bank, SSC, RRB combo courses are also on offers. APPSC, TGPSC, SI constable courses are also on offers. 0 to Hero is also on offer. Up to 60% offers are going on Republic Day offers. Telangana High Court has recently released 859 vacancies. Complete updated content course is also available on Chandan Law Exam. Telangana SI and Constable is also going to release almost 14,000 vacancies. So the people who are waiting for this notification, all of you purchase this course and start your preparation right now. Okay. RRB Group D special batch complete course is also available on Chandan Law Exam. SSC GD special batch complete course is also available. SSC CGL special batch complete course is also available. RRB NTPC special batch complete course is also available on Chandan Law Exam. UPSC CSAT complete course is also available. So occurrence of metals. Okay. So how the metals will be appear in our universe. Okay. Now we are going to discuss. Metals are found in the Earth's crust in two stages. You all know what is earth crust. The outermost layer of the earth is considered as what, students? Crust. The outermost layer of the earth is considered as what? Crust. So inside this earth crust, the metal exists in two states. So what are those? Let us discuss now. So one is free native state. What do you mean by free native state? How we will get gold, students? Okay, gold and what? Coal. We all get these from where? From earth. That is nothing but from which part of the earth? From earth's crust. Okay. So free native state are nothing but unreactive metals like gold and platinum occur in metallic form unaffected by air or water. Do you understand, students? The gold and platinum. So these two metals will not be reacted either by air or water. Remember, very, very important. So these, where do we get these metals from? We will get these metals from earth's crust. So they are unreactive metals that do not react either by air or water. Remember, very, very important. So these exist as free or native states. Okay, remember, students. So which are the metals that exist? So which are the metals that we get in free or native state? Gold and platinum. And what are the main thing to be remembered? So these will not be reacted. These two metals will not be reacted either by water or air. Okay. Next, combined state. What do you mean by combined state? Most metals occur as compounds known as minerals. Okay, we all know extraction. What do you mean by extraction? So many of us know what do you mean by mining, students. By mining only we will get all these minerals and metals. Okay, the only metals which we get in free and native states are gold and platinum, and except these two, all other metals we will get in the form of either minerals or compounds. Okay. For example, what do you mean by ore, students? Minerals from which metals can be extracted profitably and easily are called ores. Do you understand what I said? Okay. Actually, the only metals which we get in the pure form from the earth crust are either gold or platinum. But beyond these two metals, the metals which we get from earth crust, so how we will get this? We will get either in the form of minerals or in the form of compounds. Okay, how do we extract the metals from mineral students? And that elements are considered as ores. Okay, minerals from which the metals can be extracted profitably and easily are called ores. Okay, for example, these are minerals. As we are digging our earth crust, so we have there is a lot of minerals. Okay, we have digged a lot of minerals, and from these minerals we are going to get metals, and that type of metals are considered as what, students? Ores. The metals which we extracted from the minerals are considered as ores. Remember, very, very important. Okay, and what are the common ores? Include hematite, iron, bauxite, aluminium, galena, lead. Did you understand what I said, students? Okay, the metals like iron, aluminium and lead. So we will not get this in the pure form. Okay, we will not get these elements in the pure form. So we will get these elements in the form of minerals. And from that minerals we are going to extract these metals, and they are considered as ores. Okay, when we are digging the earth crust, so what type of minerals we can see, students? Like hematite, bauxite and galena, cinnabar. From these minerals we are extracting the metal which we required, and they are considered as ores. For example, when we are digging, if we get a mineral called hematite, and when we are extracting the metal from this mineral, and that type of ore is considered as iron. Okay, similarly, bauxite is an ore of aluminium, galena is the ore of lead, and mercury, it is the ore of cinnabar. Okay, aluminium is the most abundant metal in the earth crust, followed by iron and calcium. Many, very, very important. Which is the most abundant element present in our earth crust? Aluminium. After aluminium, iron, and after iron, calcium. Okay, remember students, very, very important. Okay, which is the most abundant metal present in our earth crust? Aluminium. So as of now, aluminium, we will use it in many industries. So what are the advantages of this aluminium students? They are light in weight. Okay, this aluminium is light in weight and they are corrosive, they are non-corrosive elements. Okay, they are non-corrosive metals. Next, general principles of metallurgy. Metallurgy is the process of extracting a metal from its ore and refining it. Okay, did you understand what it is? What do you mean by metallurgy? So here comes the metallurgy. Metallurgy is nothing but, so when we are mining, when we are digging our earth crust, we are getting lot of minerals. Okay, and if we are extracting the metals from that minerals, we will get ores. And that total process is considered as what, students? Metallurgy. So did you understand what I said? So when we are digging the earth crust, so what we are getting, students? We are getting minerals. Okay, the extraction of metals from the minerals, and that process is known as what, students? Metallurgy. And the things which we get are known as what? Ores. Okay. The process involves several key steps. So each and every extraction of different types of elements needs a different process, right? So now we are going to discuss those different processes. Okay? Yes, yes. So why we use aluminium for many purposes, students? Why? Because they are light in weight and they are corrosion resistant free. Okay? They are corrosion resistant. So ores. First one is crushing and grinding. So what do we do, students, actually? So at first we will crush the minerals. Sorry, we will crush the ores. Okay, we will crush the ores. Ores are first broken into smaller pieces using jaw crushers or hammer mills and then pulverized into a fine powder using stamp mills or pulverizers. How we will extract minerals from metals? Sorry, how we will extract metals from minerals means at first, what we will do, students? At first, we will crush the ores. We will crush the ores and then we will make it into a powder by using this stamp mills or pulverizers. And then this is one of the process. Okay, that is one of the process to get metals from minerals. And the next thing is concentration process. It is also known as what, students? Beneficiation. This step involved removing gangue, earthy impurities like sand and rock from the ore. Methods include. What do you mean by this concentration, students? Nothing but earthy metals like sand and rock. This sand plus rock is considered as gangue. They are nothing but they are impurities. Okay, if we remove the impurities, so finally, which one will be remain there, students? Like metal. Okay, this is also one of the metal. This is also one of the process, and in this type of concentration has many other process. Let us discuss in detail. Okay, hand picking. So used when impurities are large and distinct. So did you understand what I am saying, students? So what is metallurgy actually? Metallurgy is nothing but extracting the metals from the minerals which we get it from earth crust. Okay, so one process is what, students? Crushing and grinding, and the second process concentrating or beneficiation. So in this again many methods are there, and the first method is hand picking. If the impurities are very large, we can easily remove that impurities with the help of hand. So that is one of the method. And the next method is gravity separation. Gravity separation is nothing but based on the difference in specific gravity between the ore and the gangue, it often uses like Wifley table or a hydraulic classifier. Nothing but, so what do you mean by this method? So there is a combination of gangue plus ore. Okay, in a vessel, there is a combination of gangue. Gangue is nothing but impurities, sand plus rocks. They consist of a gangue plus ores. So what is this method actually? So take a hydraulic classifier. if you take a hydraulic classifier, the impurities which are in this combination, so they will come through this hydraulic classifier, so that we can separate the ores and gangue. So this is one of the method in this concentration method. And the next one is magnetic separation. So used when either the ore or the impurities are magnetic. For example, iron. Okay, iron ore. What do you mean by iron ore? Hematite. Hematite is the iron ore. Okay, if we want to separate the gangue from the ore, so there is also one of the method, and that method is magnetic separation. So if we put the magnet in that combination of gangue and iron, so immediately the hematite will attach to that magnet. Why? Because those are magnetic conducting materials. Okay, so that is one of the method. Next thing, fourth flotation. Fourth flotation, this method especially they are used for sulfide ores. In order to separate the impurities from the sulfide ores, so which type of method we will use, students? We will go for fourth flotation process. So what is this actually? The ore is mixed with water and pine oil. Compressed air creates a force that carries the ore to the surface while the gangue sinks. Okay, what is this fourth flotation process? This fourth flotation process, if the ore is having the impurities, by this fourth flotation process, okay, what they will do? They will mix that ore plus gangue with water and pine oil, and they will pass a compressed air to that, so that what happens, students? That carries the ore to the surface. Okay, when the air is compressed to that mixture, the ore will be attached to the surface, and which are the impurities, they will sink to the bottom. Okay, this is one of the process to purify the sulfide ore. Okay, there are many elements, there are many metals. So in order to purify, we have many other processes. So which is the best process to purify sulfide ore, students? Fourth flotation. So what we will do there? So we will add water plus pine oil into this ore plus sulfide ore plus gangue, so that what happens, students? When the air is compressed to that mixture, the ore will be attached to the surface and the gangue will be sink to the bottom, such that the ore and gangue are separated, and finally we will get the sulfide ore. Okay, next. Yes. Father of metallurgy, Georgius. Very good, Manisha. And the next process is leaching. Leaching, it is also known as what, students? Chemical method. The ore is treated with a reagent that dissolves the metal but not the impurities. What do you mean by this leaching? Leaching is nothing but it is a chemical method. So actually we will add a reducing agent to that mixture, ore plus impurities. So that what this leaching method will do, students? It dissolves the ore but not the impurities. Did you understand what I get? What I said? Leaching method is nothing but it is one of the chemical method. Okay, when we add reducing agent to this ore plus gangue, so what this leaching agent will do, student? This leaching agent will dissolve the ore but not the impurities, such that this ore and impurities are separated. Okay, next. For example, bauxite is treated with concentrated NaOH. This is also known as Bayer's process, and precious metal like silver and gold are treated with cyanide. Very, very important. So this is the leaching process, students. This is leaching process is also known as chemical method. So in order to extract silver and gold, so which type of leaching agent we will add, students? Cyanide. Such that this cyanide will dissolve the gold and silver and the impurities are separated. In the similar way, in order to get the bauxite, bauxite is nothing but it is an ore of aluminium, right? So in order to get this bauxite, in order to separate the bauxite ore from impurities, so which type of leaching agent is added, students? Like concentrated NaOH. Remember, very, very important. Okay. So this chapter is very, very important, students, for all your exam point of view. So each and every student from starting to ending. So don't even miss a single process which I am explaining. Next, conversion to oxides. So next process is conversion to oxide. So concentrated ores are converted into oxides to facilitate reduction. Okay, what do you mean by this? So conversion to oxide means the ores which are concentrated, so they will convert it to oxide such that what happens there, ores and impurities are separated. This is one of the important process. So calcination. So in this conversion to oxide, one of the method is calcination. Heating the ore strongly in the absence of air. What do you mean by calcination, students? We have discussed many times when we have gone through MCQs. What do you mean by calcination? Nothing but heating the ore in the absence of air. Okay, if we heat the ore in the absence of air, that process is considered as what, students? Calcination. This is used by carbonates and hydrated oxides to remove moisture and volatile impurities. If there are any moisture and volatile impurities present in the ores. So listen properly, students. If there are any moisture like bubbles, if there are any moisture or volatile impurities present in the ore, so which type of process we will use, students? We will use calcination. So what this calcination will do? It will heat the ore in the absence of air, such that all the moisture content will be evaporated and the impurities are removed from the ore. So this is the process when the impurities are in moisture or volatile state. Okay. Next, roasting. Roasting is nothing but heating the ore strongly in excess air. This is primarily used for sulfide ores to convert them into oxides and remove impurities like sulfur and arsenic as gases. So this roasting process is especially useful for the sulfide ores in order to remove the impurities. So how the impurities are removed means, so we are heating these sulfide ores in the excess amount of air. We are heating these sulfide ores by passing the excess amount of air, such that what happens, students, these sulfide ores, they will convert into oxides and remove impurities like sulfur and arsenic as gases. Okay, so this is one process. Next, reduction to metal. So the next process is reduction to metal. Okay, the metal oxide is reduced to the metallic state using various agents. So what is this method actually? Reduction to metal. So when we add reducing agents such that the impurities are removed from the ores. So let us see what are the different types of methods in this reduction to metal. Okay, so first one is smelting. Smelting is nothing but carbon reduction. Oxides of metals like iron, lead and zinc are heated with carbon. Listen, students, so don't think this is not that important. So it is very, very important. Why? Because there is a chance of asking you, so how the iron ore, how the iron is separated from iron ore. So did you understand what I am saying? How the iron metal is separated from the iron ore, by which process, and what is the name of that process, students? Smelting. So what is the process actually? What agent we are adding to that ore? So what is that agent, students? Carbon reduction. Oxides of metals like iron, lead and zinc are heated with coke, carbon and a flux. The flux reacts with remaining gang to form a fusible waste called slag. Okay, what is happening here, students? Nothing but oxides of metals like iron, lead and zinc, they are heated with carbon. So what happens? And a flux. Okay, so what happens when we are heating the metals of iron, lead and zinc with the carbon? So what appears, students? There forms a flux, and that flux reacts with remaining gang to form a fusible waste called slag, such that the impurities are removed and only the iron metal will be there. Okay, and the next one is aluminothermite process. This uses aluminium powder to reduce oxides of metals like chromium and manganese, generating intense heat. So in order to remove the impurities like chromium and manganese from the ores, so which type of reducing agent we will use, students? We will use aluminium powder. Okay, and the next one is self-reduction, used for less electropositive metals. Electropositive metals means I have already told you. Yeah, so this is metallurgy. Actually, this unit is not that important, but in order to cover each and every chapter, I am going to discuss each and everything. Okay, students, and what is this self-reduction? It is used for less electropositive metals. Electropositive metals are nothing but the elements, the metals which easily tend to lose electrons and form cations. They are considered as electropositive metals. Example, mercury, copper, lead, where part of the sulfide ore is oxides and then reacts with the remaining sulfide to produce the metal. Okay? Next, electrolytic reduction used for highly electropositive metals. Okay? The method which is used for less electropositive metals is, what is that method, students? Self-reduction. And the process which is used for highly electropositive metals in order to separate the metals from the ores. So what is that process, students? Electrolytic reduction. And what are the examples for this? Sodium, magnesium, aluminium that cannot be reduced by carbon. Okay, so these cannot be reduced by carbon. This sodium, magnesium and aluminium. So these are not reduced by carbon and does not form a flux. Okay, the metal is obtained by electrolysis of their molten salts. You all know what do you mean by electrolysis, students? Electrolysis is nothing but, so when cathode and anode are present in the aqueous solution, so the thing which is in the molten state that will be attached to the cathode, that is electrolysis process. Okay. Next, refining process, purification. The extracted metal is often impure and must be refined. What do you mean by liquefaction process? Separates metals with low melting points from high melting impurities by flowing them down a sloping earth. What do you mean by this process is nothing but, this process, it will separate the metals which are having a very low temperature from a impurities which are having high melting points. Okay, by flowing them through a sloping earth. So did you understand what is this? So if a ore is having metal plus impurities, okay, if we flow that ore plus impurities through a sloping earth, the metals which are having the low melting point will be separated from the impurities which are having the high melting point. So these process is considered as what, students? Liquefaction. Okay, and the next one is distillation, used for volatile metals like mercury and zinc. So which process is used for extracting mercury and zinc? Distillation process. Next, polling. Polling is nothing but, this is used for copper. And electrolytic refining, this is used for pure metals as cathode. In order to get the pure metals, which type of process we will choose, students? Electrolytic refining. Okay. And for copper, which type of process we will choose? We will choose polling. Okay. And for mercury and zinc, which type of process we will choose, students? Distillation. Okay. Next, zone refining, used for ultra pure metals. In order to get ultra pure metals, that means 24 karat gold, which type of metal we will choose, students? We will use this zone refining. It relies on the principle that impurities are more soluble in the molten state than in the solid state. So what is this actually? So impurities which are present in the metals, these are more soluble in the molten state than in the solid state, such that the metal which we are getting, it will be very high, ultra pure. Okay. And the next one is Van Arkel method. Van Arkel is nothing but involves converting the metal into volatile unstable compound and decomposing it at high temperature to obtain pure metal. Example, titanium. Okay, what is this actually? Van Arkel method is nothing but titanium. We are heating the titanium with iodine at 550 Kelvin temperature. Okay, I am explaining the process. Listen carefully. Okay, in order to get the pure titanium, so what process we are opting is that titanium, okay, the impure titanium, we are heating the impure titanium with iodine at 550 degrees Kelvin, such that the thing which we are getting after heating this titanium plus iodine is titanium vapor. Listen properly. Titanium vapor. Again, if we heat this titanium vapor at 1800 Kelvin, so what happens, students? Iodine is separated and the pure titanium we will get. So remember, what is this Van Arkel method? This is very, very important. Okay. Titanium, the impure titanium. Okay, the impure titanium. It is actually impure titanium. We are heating this impure titanium with iodine at 550 degrees Kelvin. So what you will get, students? We will get titanium vapor. Actually, this is vapor. And again, if we heat this vapor at 1800 Kelvin, so the thing which we get is pure titanium plus iodine. Okay, this method is known as what, students? Van Arkel method. So these all methods are nothing but in order to get the pure metal without any impurities. Okay, and the last one is cupellation. Used to refine silver by oxidizing lead impurities into lead monoxide. So in order to get pure silver, so what we are using, students? We are using the oxidizing agent as lead impurities. So in order to remove the lead impurities from silver, so what we are doing? We are adding the oxidizing agent lead monoxide, which is then carried away by a blast of air. So did you understand what I am saying? So we want to get pure silver. So what type of method we are opting, students? We are choosing cupellation method. So what this method is doing? This method, okay, when we are passing an oxidizing agent to this silver which is having impurities, so the lead which are present in the silver, they are converting into lead monoxide and they are going away by blast of air. So this method is known as what, students? Cupellation, and this cupellation method is useful for silver in order to get pure silver. Okay. Next, so questions. So these are the important methods, students. I think everybody is confused, but I will explain and again, don't get confused. So which side of the periodic table do metals generally occupy? Right side, left side, center, zigzag line. So tell me, students, I have told you already in the beginning of the session only. Okay, so on which side of the periodic table metals will be located? Metals are located. So tell me, students. Each and every students mention your answers in the comment section. What is the answer for this question? Very good. So till now, if you did not understand anything, so don't worry, students. In the questions, I will explain you clearly. Okay. So what is the answer for this question? Left side. How many electrons do metals typically have in their outermost shell? 4 to 8, 1 to 3, 0, 8 only. I have explained you in the beginning only. So metals have how many valence electrons in their outermost shell? And non-metals will have approximately 4 to 8 outermost shells. Okay. So these metals are electropositive. They easily lose electrons and they transform into cations. And when it comes to these non-metals, they have 4 to 8 in their outermost shell and they are electronegative. That means gain or share electrons to form anions. Okay. 1, 2, 3. Very good. Which of the following is not a general physical property of most metals? High tensile strength, good conductors of heat and electricity, brittle in nature, solid at room temperature except mercury. Which of the following is not a general physical property of most metals? So tell me, students, high tensile strength. Yeah, tell me. In the given options, so which is not the property of metal? I have told you in the beginning of the session only, students, this metal will have high tensile strength. High tensile strength is nothing but what, students? If we heat the metal, that metal can be stretched. How they will be stretched? By hitting with the hammer. Okay, if we heat the metal, so what is happening in the welding process, students? Welding process is nothing but heating the metal and striking it with the hammer. That means the metal can be stretched. The metal can be pulled if we heat it. That is nothing but it is having the high tensile strength. And not only that, the metals are good conductors of heat as well as electricity. And one more thing is that, so metals exist as solid at room temperature except mercury, but they are not brittle in nature. Example, Non-metals are brittle in nature but not the metals. So option C is the correct answer. Very good. Very good, students. Anita, very good. Okay, I have already explained each and everything. Yes, brittle nature is in non-metals. Next, which non-metal is an exception because it conducts electricity? Sulfur, phosphorus, graphite, oxygen. Now tell me, students, I have already told you metals are good conductors of heat and electricity, but non-metals are poor conductors of heat and electricity except one. What is that? Tell me, which is the only non-metal that is a good conductor of heat and electricity and it is lustrous in nature? No, Black Panther, you are just randomly giving the answers. Have already explained you. Very good, Tirthi. Okay, the only non-metal which is a good conductor of heat and electricity is graphite. Okay, graphite, it is nothing but it is an alloy of carbon. We have discussed about this graphite many times. Okay, which element is commonly listed as a metalloid? Sodium, silicon, chlorine, calcium. So tell me, I have already told you what do you mean by metalloids. Metalloids are nothing but they are located in the zigzag line between metals and non-metals on the periodic table. So they behave both as metals as well as non-metals. Okay, now tell me which is the only examples that is in the given 4 options. So that is a metalloid. Metal is nothing but it acts as both metals and non-metals. It have both the properties of metals and non-metals. So which is the one which is metalloid? Very good. So not only that, students, boron, silicon, germanium, arsenium and tellurium. So these are the examples for this metalloids. Very good. Okay. What is this? Silicon. Sodium is a metal. The only metal which have less density, the only metals which have less densities are sodium and potassium. For this purpose only they are stored in the kerosene. Remember, students, each and every point is very, very important. Even though if you had not listened my explanation part, I will explain even these MCQs also, students. Don't worry. Okay. How many metalloids are traditionally recognized along the zigzag line? 3, 5, 7, 9. So tell me, how many metalloids we have? Boron, silicon, germanium, arsenium, tellurium, and finally, how many zigzag elements are considered as metalloids? So who is going to give answer to this question? Tell me, students. I have already displayed them. So tell me, 6 or 7 or 9 or how many? How many metalloids are present on the periodic table in zigzag line? Come on, students, hurry up. Who is going to give answer to my question? Very, very important. Give me the correct answer. Don't guess, students. Give me the correct answer. We have already discussed them. Boron, silicon, germanium, arsenium, tellurium and 2 more. Okay. So almost 7. Very good. Very good. Very good. So if you don't know the answer also, just imagine, students, how many periods we will have. How many periods? 7. So in this manner also we can say. Okay, let us check this. So these are metals, right? Okay, 1, 2, 3, 4, 5, 6, 7. 7. Done? Okay, not 9 Joseph Jayasuriya. They are 7. Next thing, which metal is most likely to occur in the free native state in nature? Iron, aluminium, gold, sodium. Have told you already, students. So metals can be existed in two states. So one are in free or native, and one more thing is compound or mineral states. Okay. Now tell me which is the most likely to occur in the free native state in nature. That means there are no impurities added. That means that does not react either by air or water. What is that? Very good. No. You are not answering well, students. So what is the answer for this question? I have already explained you the difference between. Okay, once again I am saying, in the given option, that metal, it will not be reacted either with air or water. Now tell me the answer. No, students. Gold, Kausalya. Very good. Okay. So which metal is most likely to occur in the free native state in nature? I have told you already, students. So where does we get these metals from? We'll get these metals from earth crust. Okay. Earth crust is nothing but it is the outermost layer of our earth. So when we are digging our earth, we will get lot of minerals, and from that minerals, by extracting that minerals, we will get ores. Okay, but the only metal which we get in free or native state is nothing but gold or platinum. Did you get my question now? Yes. Next, the most abundant metal in the earth crust is iron, calcium, aluminium, magnesium. So I have already discussed about these also. Which is the only metal that exists more abundant in our earth crust? So we will use it for many purposes. It is light in weight and it is non-corrosive metal. Okay, and the atomic number of that is 13. Now tell me the answer for that. Aluminium. Very good. Okay, after aluminium, iron, and after iron, calcium. Okay, yes. Minerals from which metals can be extracted profitably and conveniently are called gangue, ores, alloys, slags. Now tell me, students, the metals from which metals are extracted, and the things that are extracted are considered as what? I have explained about these also. Tell me, minerals from which metals can be extracted profitably and conveniently are called ores. Very good. For example, bauxite is an ore of aluminium and hematite is an ore of iron. Okay, cinnabar is an ore of mercury. Very, very important. Okay. Next, which of the following is an ore of mercury? Hematite, bauxite, cinnabar, galena. Now tell me, what is the answer for this question? Just now I have explained you. Bauxite is an ore of aluminium. Minerals from which the metals can be extracted that are considered as ores, right? So hematite is an ore of iron. Bauxite is an ore of, all ores are minerals, but all minerals are not ores. Very good, Anita. Very good. Okay. Which of the following is an ore of mercury? Cinnabar. Very good. Just now I have told you. Hematite is an ore of iron. Bauxite is an ore of aluminium. Then galena is an ore of what? Tell me, students. Galena is an ore of lead or what? Tell me. Yes. What is the answer for this question? Galena is an ore of which mineral? Which metal? Who is going to give answer to my question? Tell me. Recall. Very good. Lead. Okay. The first step after mining in metallurgy is usually reduction, crushing and grinding, refining, calcination. So tell me, after mining the ores, the first step in order to extract the metal is what? Tell me. What we will do after extracting the mineral? What we will do? What is the first step after extraction of minerals? In order to extract metals from the minerals, what is the first step? Crushing and grinding. Very good. Okay. Which concentration method is most suitable for sulfide ores? Magnetic separation, gravity separation, fourth flotation, hand picking. Now tell me, I have told you already. So which method is useful for the extraction of sulfide ores? Yeah, tell me students. So what is this actually fourth flotation process is nothing but in order to remove the impurities from the sulfide ores. So what we are adding students, we are adding water plus pine oil. So such that what happens when the air is compressed to that mixture, the impurities will blow away from the sulfide ores and only the sulfur will be remain. And that process is known as what students? Fourth flotation process. Very good. Black Panther, all your answers are wrong. Next. In the Bayer's process, which ore is treated with the concentrated NaOH? Galena, bauxite, hematite, cinnabar. Now tell me. So in order to extract silver and gold, so which reducing agent we will use means like a cinnabar. Okay, in the similar way, in order to get which type of element, which type of ore, we will use concentrated sodium hydroxide. Tell me students, very good Anita, very good, you are answering very well. Bauxite. And cinnabar is used to get silver and gold. Okay. Just try, give a try, okay? Parshuram. Next. The chemical method of concentration that selectively dissolves the metal compound is called levitation, leaching, roasting, smelting. Now tell me. So what do you mean by chemical method? Chemical method is also known as what? So what is happening in this metal is that, okay, so an agent is, a leaching agent is added to that a particular metal which is having impurities such that that leaching agent will dissolve the metal and the impurities will be remain as usual. Okay, that means nothing. What is happening there? The impurities and the metal are separated by dissolving the metals in this leaching agent. So what is the answer for this question? I have already told you the answer also. Chemical method is also known as what? Leaching method. So what is this leaching method, students? Listen properly. In order to remove the impurities from the ores, so what we are doing here, we are adding a leaching agent such that what this leaching agent will do, this leaching agent will dissolve the pure metal and the impurities are remain as usual, such that what happened here, the impurities and the metal are separated. Okay, so this method is also known as chemical method. Okay, next. Calcination is typically used for converting sulfide ores to oxides, carbonates and hydrates oxides to oxides, oxides directly to metals, native metals to compounds. What do you mean by this calcination process? Calcination process is nothing but heating the ore in the absence of air. Okay, heating the ore in the absence of air. So where we will use this calcination process mostly? In which compounds? Very good. Carbonates and hydroxide oxides to oxide. What do you mean by calcination? Calcination is nothing but heating the ore in the absence of air. Okay? Very good. Next. Roasting is primarily carried out by carbonate ores, sulfide ores, oxide ores, halide ores. Roasting, what is this roasting process, friends? Roasting process is nothing but heating the ores in the excess presence of air. Okay, so this process is applicable to which type of ore? Tell me. I'm not laughing. This session is... So what is the answer for this question, students? Yeah, roasting for sulfide ores. Very good. Remember students, if you do not have idea regarding these chemistry chapters, just remember the key points. For example, roasting sulfide ores, calcination, carbonates and hydroxide oxides. So just remember these type of things. Okay. What is the answer for this question? Sulfide ores. Next, which reduction method uses coke and flux to produce slag? Alumino-thermite process, electrolytic reduction, smelting, carbon reduction, self-reduction. So tell me. So in order to remove the impurities, so if we add a carbon reduction agent like coke, such that slag will be formed, okay, flux will be formed. And if that flux is added with water, and that combination is known as slag. So this type of method is known as smelting. Very good. The alumino-thermite process is commonly used to reduce oxides of sodium, aluminium, chromium, mercury. So if we use this alumino-thermite process, so which type of it reduces oxides of water? Chromium or aluminium? So listen students, if you read the concept in the depth only, you can able to reach your target. If you read the concepts like what paina, okay, that is not okay. You have to read the concept in depth, and this is the example for the depth concept. And what is the answer for this question? Very good. Which metal is extracted using the self-reduction process? Magnesium, copper, sodium, potassium. Now tell me the answer for this question. Which metal is extracted using the self-reduction process? Answer for this question, sodium. Very good. Electrolytic reduction is essential for extracting high electropositive metals such as iron, zinc, aluminium, lead. Okay. What is the answer for this question? Copper polling process. Okay, copper for polling process. And what is the answer for this question? Electrolytic reduction is essential for extracting highly electropositive metals such as zinc. Okay. Next. Which refining method is based on the difference in melting points? Zone refining, electrolytic refining, liquefaction, cupellation. I have already told you, if we pass the metals which are having low temperature, low boiling point, and if the impurities which are having the high boiling point, if we pass them through a floating earth, so they are separated. That type of process is known as, okay, liquefaction. The Van Arkel method is used for obtaining ultra pure iron, copper, titanium, lead. Yes. And tell me the answer for this question, students. I have already told this Van Arkel method. Van Arkel method is nothing but, in order to get the pure titanium, if we heat the titanium impurity with iodine at a temperature of 550 degrees centigrade, the thing which we get is titanium oxide, which exists in vapor nature. Okay, and again if we heat that titanium vapor at a temperature of 1800 Kelvin, so the thing which we get is a pure titanium. Okay. In electrolytic refining, the impure metal is used as the cathode anode electrolyte flux. The impure method is used as, yeah, tell me students. In electrolysis process, cathode will be there and the anode will be there. So the impure metals are coated at the very good. Next. Match the following incorrectly paired pair. Polling, copper, cupellation, silver, fourth flotation, oxide ores, roasting, sulfide ores. So, tell me the correct answer, students. Fourth flotation. What is the incorrect pair in this session, in this MCQ? Okay, and the answer is fourth flotation. Why? Because this is not sulfide oxidation, this is sulfide. Okay, sulfide ores. Next. Which refining technique depends on the principle that impurities are more soluble in the molten phase than in the solid phase? Distillation, liquefaction, zone refilling, and polling. What is the answer for this question? Distillation is useful for mercury, right? Okay, and what is the answer for this question? Distillation. Up to 60% offers are available on our Chandan Likes app. Any course you can get it only for 499 rupees. Bank exams are also available on offers. SSC exams complete course are also available on offers. Railway exams are also available on offers. Bank, SSC, RRB combo courses are also available on offers. APPSC, TGPSC, police, SI and constable courses are also on offers. Up to 60% offers are going on. 0 to Hero complete course are also available on offers. Telangana High Court has recently released 859 vacancies. Complete course are also available on offers. Telangana SI and constable course. It is going to release 14,000 vacancies. Complete course are also available on Chandan Likes app. RRB Group D complete course is also available. SSC GD complete course is also available on Chandan Likes app. SSC CGL complete course is also available. RRB NTPC special batch complete course is also available on Chandan Likes app. UPSC CSAT complete course is also available. So each and every course are available both in English as well as Telugu languages. Okay, we have 3 channels: Chandan Likes Telugu, Chandan Likes English, and Chandan Likes main channel. So subscribe to those 3 channels such that whenever there is a live session, you can attend to that live session. Take care, bye students. Let's meet in the evening session. Women fighters, okay?